Alright, so in this video we're going to review fluid kinematics, specifically the difference between Lagrangian and Eularian descriptions of fluid flow. Okay, so first let's ask, what is fluid kinematics? And so kinematics is probably a term you're familiar with before, but basically kinematics provides us the terminology needed to properly describe motion. And so, the way I like to think about it is it's the language of motion. It's the terms, it's the concepts that we need to just talk about how motion is. And I think a concept you're probably familiar with is kinematics from classical mechanics. And so I think kind of the most classical example of this is describing projectile motion. And so if you have a catapult, say down there, and it launches a boulder at an enemy nation, and so you can describe the motion of that catapult of that boulder using its displacement, its velocity, and its acceleration. Just to name a few, and we have equations that relate these to all of these quantities. And so for fluid motion, it's a little bit more nuanced, and so it's a little bit more complex than that. And so there's different ways that we can describe fluid motion. And so the first is Lagrangian, and the second is Eularian. So first, let's review what Lagrangian kinematics is. And so Lagrangian kinematics it's kind of the most what I like to think is most closely resembles classical kinematics. And so when you look at fluid flow, say you have water flowing from your sink or water flowing in a river, think about tagging individual fluid particles and tracking those particles throughout the motion. And so each particle, just like the boulder on the previous slide, has its own displacement, velocity, and acceleration, and we can follow that, throughout the entire motion. Okay? And so a good analogy that I like to think about from Lagrangian is to think about, say you're studying a pack of migrating birds. And so the Lagrangian way to do this would be to kind of capture individual birds, put a tracker on its foot, and then let it go, and then use that tracker to send information via GPS to track kind of the overall motion of the flock. And so, of course, you can't do this for every single bird unless you're a mad person, but, just based on the few that you capture, you can then use that information to track, what direction, how fast they're going, things like that. The other way to describe fluid motion is known as Eularian kinematics. And so instead of tracking individual particles, we instead look at the fluid as a continuous medium or continuous field where you can measure fluid properties at fixed locations. And so the way I like to think about this is that, think about placing probes at fixed locations within the fluid and then measuring, the velocity, the acceleration of the fluid as it goes past that probe. And in fact, the Eularian description, because fluid is such a fluid medium, pun intended, this is kind of the standard way that we use to describe fluid flow. And a lot of the equations that we learn in fluid mechanics, is based on the Eularian description. And so going back to our analogy from before, and so if you go back to the migrating birds, and so instead of studying the birds via individual trackers, what you're going to do instead is place cameras or place some kind of measuring stations at fixed locations, and then along their migratory path, and then counting each bird that goes past the camera, and you can see how fast they're going, such like that. And so based on how many birds that you count, and how long it takes birds to go from one camera to the next, you can infer information about bird speed and acceleration. And so Eularian kinematics is, that's kind of how we think about it. And so when we look at a fluid flow, we think about, what's the velocity of the fluid at this location? What's the acceleration of the fluid at that location? And so this is the more standard way to do it. But that said, there are applications for Lagrangian. It's just not as commonly used.